Alright guys, we're going to get into Unit 1, but first of all we need to go over some definitions. But just like a lot of your notes, you can find it in Google Classroom. Remember, under the classwork, math notes, click on the slides. I've already took the liberty to scroll down to Unit 1 definitions. Boom. I think it'd be a good idea for you to just go ahead and pause the video and or open your own notes and start copying these two charts. You're going to need them. Okay? Algebraic expression does not have an equal sign. Here's an example, 2x plus 3. A variable, obviously it's going to be letters that representing values that change. Okay, an example would be 2x, x being the variable for this. Term, these are separated by a plus or minus sign. So for example, if I had 3x squared plus 2x plus 1, my terms would be 3x squared, 2x, and then the 1. Like terms are terms with the same variable. So 3x plus 2x, and if you went ahead and took the initiative and simplified that, you would have 5x, because 3 plus 2 is 5. Coefficient will be the numbers in front of the letters. So if I gave you an example like 16x to the 5th power, and I asked you what the coefficient is, your answer should just be 16. Alright? Again, you need to go ahead and pause the video so you can jot this down or open up your notes. But an exponent will be the power a number is raised to. So in this situation, if I had 16x to the 5th power, 5 would be my exponent. Base is going to be the number of variable raised to a power. So in this example again, 16x to the 5th power, x would be my base number because it's the variable for this example that's being raised to some power. Constant would be numbers without letters. So, or variables, because that's what we're going to start using, not letters. We're going to call them variables. So for -3, those would be constants. There's no variable, no a, b, x, y, nothing. It's just the numbers. Factors are going to be items multiplied together to create terms. So if you had 3 and x squared, and you're multiplying it, well, you would get 3x squared. In order of operations, well, that's PEMDAS. You've already heard all the acronyms under the sun, and I got the posters in the room to prove it. So, now that we got all that jotted down, boop, 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 boop. So, this is what I want you to do. We're going to identify each term, coefficient, and constant. You're going to want to jot down this algebraic expression, and you're going to list the terms, coefficients, constants, and the factors. Go ahead and pause the video so you can try this out on your own. Alright, so we're back. So for the terms, you should have 4x squared, 3x. I need you to notice right here, that negative goes with the 7. So -7 would be your last term. Coefficients, again, were just the numbers in front of the variables, so 4 and 3. Constant would be just the -7. The factors are things being multiplied, so 4 and x squared, 3x. Some might argue that you have -1 times 7 over here, but we're not going to get into that. Number 2, you should have 6x cubed minus 5x squared. Oops. We don't need that positive sign there. Column 3x and then -7. Coefficients, 6, -5, don't forget the negative. Tree, constant, -7. Factors, things being multiplied, so 6x cubed, -5x squared, and 3x. So go ahead and pause the video if you need to again to jot down your answers. And again, these are your notes. You're going to need them for later. Here's 2 more examples. Go ahead and pause the video here and try them out. But fun fact, simplify this guy and then pull out your terms and coefficients. Alright, we're back. So you should have got 12a cubed, 16a, and 4 for your terms. Coefficients, 12, 16, no, not 4, because 4 is a constant. And factors would be 12a cubed, 16a, and that's it for that one. Now down here, we have some like terms. And I told you back when we were solving these things, do that first. So what's 21 minus 15? Good, 6. So 6x squared plus 3x plus 9. Now write down your terms. So 6x squared. And then we get 3x. And then we get 9. Coefficients should be 6 and 3. Constants 9. And your factors should be 6x squared and 3x. Now, this should be deja vu from middle school. I'm just saying, if not, this is all news to you. Well, you better be writing this down. Because trust me, this is going to be a test question. And you'll be surprised how students really do miss it. Anywho, I'm going to put a smiley face here because we all need to keep our smiles up. You should have this worksheet in front of you now. If not, better go get it from the sub because now you're going to try this out. Again, deja vu. You should be able to pull out all the addition words, subtraction words, division words, multiplication words, and yep, those exponent words. Obviously, the exponent words are going to be the ones you didn't use. I've also put parentheses around how many you should be pulling out. So, process elimination, once you use the word, cross it out. And at this point, you would want to pause the video, try it out yourself, and then we'll come back and see if we get the same thing. Alright, we're back. Let's find out all the addition words. Yep. Plus is one of them. More than. Let's see. Some. Let's see. Increased. That's another good one. So that's 4. Add. Duh. There's 5. And we'll use together. Because we're all in this together. Ha! I'll change color so I can keep things organized. Subtraction. Let's see some. Ooh, difference is a good word. Ooh. Decreased. Sometimes you'll hear decreased by. Let's see what. Less than. Notice it says swap the order. That's a big problem a lot of students forget to do is flip the order. It's going to make a difference down the road. Let's see. Take away. Kind of like I take away your cookies. And minus. Skadoosh. Division, there's only 3 words. Let's see if we can find them. Half would be a good word. And that would be dividing by 2, in case you didn't know. Oh, I was going to change colors. Let's make it green. Oh, would you look at that? Didn't turn green, now did it. There's green. I'm going to scribble that out. And then I'm going to erase it because I'm that extra. So, half And again, if you didn't know, that's divide by 2. Let's see here. Quotient. That's not a good word. Quotient. And obviously divide by. If you miss divide by, I weep for humanity. So, I think we got all those words down. Notice what we have left. We have triple, the power of, twice, raised to the power, cubed, product, times, doubled, and square. So I'm going to flip the page real quick. And let's finish this off. So we already used half, we used plus. Triple would be for multiplication. And remember, that means you're timesing by 3. We did more than, we did difference, we did sum, we did decrease twice. That's another good multiplication word. And that means times 2. We already did less than. We did take away, we did increase. We did minus, we did quotient. Product means you multiplied something. We already did divided by. Double. Remember, that means times 2 again. We got 1, 2, 3, 4. We need one more word. That's right, times. There we go. We did together. And now you're just left with square, cubed, raised to the power of, and to the power of. I don't know why I put in of after that. So I'm going to change colors and I'll write those down real quick. To the power of, raised to a power, cubed. I'll show you an example, like x to the third. This would be an example of something being cubed. And square. An example here would be x to the second. The square part is the second. So, as you can look through 1 through 4 here, I either need to write an expression based off the words, or if you have an expression, convert it to the words. Use your math words. You have a list. Go ahead and pause the video and try it out. Alright guys, y'all should have plenty of time. Again, if you pause the video and try this out. So, if we have the sum of a number and 10, sum means to add. You should have had n for number plus 10. Product means to multiply. So when you see the product of 9 and x squared, you should have 9x squared. Number 3, 9 less than g to the 4th power. This is a turnaround word. So g to the 4th power minus 9 is how you should write that. I don't like how that looks. Let me rewrite that. G to the 4th minus 9. I tried. Anyway. And number 4, I don't know. We could say maybe the sum of 8 and 3 times a number. That one could have worked. I mean, it's almost up for debate as far as how you could write this. But I think the sum of 8 and 3 times a number is good. So, there you go. Moving on. Again, go ahead and pause the video, try this out. And let's compare answers. Alright, we're back. Number 1 says identify the term, coefficient, constants, and factor. Just like what we did earlier by making the table. I'm going to start off with terms first. So 5x squared, 3x, 12. These are going to be the terms. Next would be coefficients. So 5, 3. Constant would be 12. Factors would be 5x squared. Put a little comma there. 5 and x squared. And we have 3 and x. Write an expression with 4 terms containing the coefficients 3, 6, and 9. So this could just be almost anything, but we got to make sure we have 4 terms that have these coefficients. Let's just keep it simple. 3x cubed plus 6x squared plus 9x. Now let's make some constant. I'm going to put 1 because I'm number 1. We have 4 terms. 1, 2, 3, 4. Yep, this looks good. If yours has 4 terms, if you have these coefficients, your letters could be Z's, Q's, G's. Any letter in the alphabet, you're golden. Down here it says translate each verbal expression into an algebraic expression. So read the sentence and write the expression. So go ahead and pause the video and take a second to knock these out. Maybe not a second, maybe a minute, maybe 5 minutes. Shouldn't take you longer than 15, so let's not get, too distracted in class. Alright, I guess we're back now. We have 8 more than 3 times the number. So I'm going to put 8. More than means to add 3 times the number. I'm just going to put 3x. Number 4, the difference of 10 and a number. So 10 minus x. Write it in order. The quotient of 12 and a number. Remember, quotient's on top, denominators on the bottom. So 12 divided by x. Sorry about that, I got distracted. Where are we? 6? What we got? 15 less than twice the number. Boom. 2x minus 15. There we go. 7 3/4 the square of a number. 3/4 square of a number. Skadoosh. Product of 5 and the cube of a number increased by the difference of 6 and x. Holy moly. So we got a product of 5 and the cube of a number. So let's see. We got x cubed here increased by, increased by the difference, of 6 minus x. Shoo! So we got product, and we multiplied here. So product of 5 and the cube of a number increased by the difference of 6 and 8. Guys, I think that's it. So I'm going to just write it just a little bit nicer. And you know what? If you don't like it, call somebody. Who cares? Alright. Half the sum. Alright, half the sum of x and y decreased by 1/3 y. Half the sum of x and y decreased by 1/3 y. Looks good to me. The sum of a number and 6 divided by 8. I'm happy with it. Translate each algebraic expression to verbal expression. I got 25 minus x. Shoot, did you just hear what I said? 25 minus x. Easy peasy. I'm going to say x. I'm going to use to the power of 4 decreased by, let me make this look a little better than that. Decreased by 12. And look, I don't know if you can see this on your screen or not. Look down here. It's 11:13 p.m. Will I make mistakes? Maybe. Does this show how much I care that we don't waste any time? Yes. You better be working on this. 3 plus half x. Alright, I'm back. Sorry about that. Sorry for all the interruptions. I'm just trying to take care of this, trying to take care of that, and trying to take care of this video for you guys. 13. We got 3 plus half. You know what? Just like you read it. 3 plus half a number. Man, my writing has gotten garbage when it gets late at night. We have 8 squared minus a number. We'll do that. 8 squared minus a number. 15. We can say 6 minus a number and then put divided by 13. And 20, or not 20, am I saying 16? We can say 25 times 6 plus a number. And I think that's good enough for government work. We're done with that worksheet. These are your notes. Punch holes in it, stick in your binder, etc., etc. We got one more thing to look at, and I'll be done with this. We need to start writing equations. So I hope you still have those notes out from the slides, because we're going to reference those for numbers 4, 5, 6, 7, 8. But go ahead and get that worksheet out now. Sub has it in the folder if it has not already been passed out. It says writing and solving linear equation practice. I've given you yet again steps. Draw a sketch if necessary. Define a variable. Setting up an equation. Solve the equation. Make sure you answer the question. So, you all already did this. We already had a video. Y'all worked these out already. And this is the worksheet I was discussing. I've already given you steps. All you need to do is follow them. So, the sum of 38 and twice a number is 124. The sum of 38 twice a number is an equal sign, 124. From here, you solve. You already took a test on how to solve. I'm telling you, you're going to be solving for the rest of high school. Do the opposite. So we need to subtract 38 from both sides. Bring down your leftovers. 124 minus 38 is going to be 86. Divide by 2. X equals 43. Says find the number. We did. Looking good. And again, I know we discussed it, but I'm just going to go ahead and show you. If you had 38 plus 2, we plug in the number we just solved for. It should equal 124. I'm using my calculator. I'm pressing this in. 38 plus 2 times 43. And indeed, I get 124. That equals 124. That's a true statement. We did the right thing. Whew, number 2. That was just to warm you up. I expect you to go ahead and pause the video now and try to solve 2 and 3 by yourself. Alright. Let's see if you got the same thing I did. We have 12 subtracted from 3 times a number. So look, that's kind of like a hidden turnaround word right here. Subtracted from. So it's like we started off with 3x. We subtract the 12. And this should equal 15. A lot of students got that backwards. So go ahead and fix your mistake. Maybe make a little note if you need to. That, you know, subtracted from is like a turnaround word. And then go from there. You have an equation. Start solving for x. Add 12 to both sides. 3x equals 27. Divide by 3. X equals 9. Again, I'm not going to rewrite it. Just quickly self-check. 3 times x, or you got 3 times x. We're putting 9 in for x. So 3 times 9 is 27. 27 minus 12 is indeed 15, so that works. If you haven't done so already, go ahead and pause the video. Try to knock out 3. Alright, so 7 less than 3 times the number, so 3 times the number, less than is a turnaround word, is 43. We have our equation, says find the number, add 7 to both sides. So 3x, because those cancel, that's going to be 50. Okay. Divide by tree. X equals 53. Or 50 over 3, excuse me. I don't know why I said 53. Again, it's late. We're almost at midnight. So, I know you might be a little concerned about this. So just go ahead and plug that in. Let's make sure it's still balanced. So 3 times 50 over 3 and made the substitution for x minus 7, and that should equal 43. Look, 3's cancel, so 50 minus 7, yep, that works. Just because you got a fraction, still works. Now we have this new kind of terminology down here. It says find 2 consecutive integers whose sum is 83. If you go back to your notes, right after this one, come down here to consecutive integers or numbers in a row. Example 4, 5, 6, 7. So an algebraic expression for consecutive integers will be x, x plus 1, x plus 2, x plus 3. Alright, sounds easy enough. Let me explain real quick where this equation comes from. Let's just go with the basics. If we had 1, 2, 3, 4, 5, these are consecutive integers. And where that formula comes from is, well, let's say the first one's x. How do you get from 1 to 2? That's right, you add 1. Okay, plus 1. How do you get from 1 to 3? You add 2. How do you get from 1 to 4? You add 3, and so forth, and so on. That's where it comes from. We'll try to talk a little more about this in class, but this is the best way to explain it. We have consecutive numbers. If I wanted to get to the next one, I just add 1. If I wanted to get to the second one, I add 2. The third one, I add 3, etc., etc., and just keep that pattern up. So when we say find two consecutive integers whose sum, hence the adding in between, is 83, I'm looking at the x plus 1, because this is the first one and this is the second one. The sum of these two should be 83. So x plus 1 should equal 83. Another way to look at it that students like to do is stack it. X plus 1. This is the first term, second term. The first consecutive integer, the second consecutive integer. It says to add them up, so I'm just going to put a plus here. First and second, so x, 1, 2, 2 x's, plus 1, this should equal 83. Guess what? We have an equation. Time to solve. Sorry, I'm straight mark right there. Here we go. Subtract 1. Now we have 82. 2x divided by 2. And we get x equals 41. This is telling me my first consecutive number is 41. So let's put that idea up here. 41. 41 plus 1 would be 42. Again, consecutive integers. These two, if you were to add them, 1 and 2 is 3. 4 and 4 is 8. Indeed, we get 83. So we found the consecutive integers whose sum is 83. Mathematically, of course. Boom. Boom. All right, let's keep going. So, here's your notes for consecutive integers. Algebraic expression, even, look, you already have these right here. Definition, algebraic expression, even consecutive integers is going to be x plus 2, x plus 4. Notice something. Even and odd, 6, 8, 10, 7, 9, 11, they have the exact same formula. Okay? Didn't mean to move that. Let me scroll down a little bit. Here's your example to find 3 consecutive integers that add to be 48. 1, 2, 3. Add them up. 4 consecutive even numbers. Again, these are notes. I'm going to be referencing these notes. If I need 4 consecutive even, well, I'm going to have, here's one of them, here's the second one, here's the third one, here's the fourth one. Same thing for odd, first, second, third. And I'm just going to follow my notes, guys. Go ahead and pause the video, take these notes down, copy them. I'm going to explain it on the slide real quick, but I'm referencing notes. That's why we take notes in math class. So when it says, again, these are your notes. We kind of deviated from the worksheet real quick so we can take some good notes. And as you can see, these are back on the slides. Now I'm trying to stay consistent here. Okay. Find 3 consecutive integers. Well, we already discussed that part. This is the first. This is the second. And this is the third. 3 consecutive integers. Add those up, we get 3x plus 3 that need to add up to 48. I'm just going to come up here and solve it real quick. Because again, we should be pros. So that's 3x, 45, divide by 3, x equals 15. So your first one is 15, 16, 17. Real quick, hit up your calculator. 15 plus 16 plus 17, boom, 48. So my answer, because I like to list it, it's going to be that. Now, to feed off of this idea about finding 4 consecutive even integers that add to be 100, let's see where that comes from. Let's list even numbers real quick. 2, 4, 6, 8. Just like I did earlier with the consecutive integers, just count and see how you get from them. So 2 to 4, you add 2. 2 to 6, you add 4. 2 to 8, you add 6. This is that pattern that we were discussing. Go back to your notes. Right here, that idea of just adding what we need to get to the next number. 6 to 8, you added 2. 6 to 10, you added 4. The x obviously represents the 6. Okay? We should start recognizing these patterns. And again, I'm just going to regurgitate this so you can get it from the notes. Oh, dang nabbit. I'm trying to open this back up. And again, while I'm on the subject, odd numbers, I'm just going to list a couple. We got 1, 3, 5, 7. Notice you get the same jump. 1 to 5, you add 4. 1 to 7, you add 6. 6 plus 1 is 7. 4 plus 1 is 5. 2 plus 1 is 3. We have that same number of jumps. And let's face it, when you're done working this out, for example 1, you should get an even number. For example 3, you should be getting odd numbers. If you're not getting it, you did something wrong. So, with all this background taken care of, let's go ahead and work it out. Find 4 consecutive even integers. So our first one, where we start, is going to be x. Second one is going to be x plus 2. Okay. Even third x plus 4, and I'm telling you, we need to remember, even odd, we do the plus 2 plus 4. Fourth is going to be x plus 6. Add them up. 6 and 4 is 10, plus 2 is 12. 1, 2, 3, 4 x's. All that should be 100. Sum had to be 100. So 4x plus 12, and now we're just solving. So subtract 12. 4x equals, let's see, that's 100. 100 minus 12 is what? Come on, you can do it. 88. Good. Divide that by 4. 88 divided by 4 should be 22. As I said, should be an even answer. So first one's 22. Add 2 to that. The next one's 24. Keep the pattern going. These should be your 4 consecutive even integers. Take a second, add them up. 22, 24, 26, 28. Boom, 100. That's the right answer. Shoo. Man, it's getting late. How much? Let's see if we can't fly through example 3. Probably going to do 5 and 6, and we'll save the rectangle for later. That might be our plan for tonight, because it's getting late. I got to go to sleep. You got to watch this video, and I got to punch in the grades in from today. So let's wrap this one up. Odd integers, we need 3 of them. So x, that's the first one. Second one, remember our notes. Our notes say should be x plus 2. We already discussed this. Third would be x plus, dad nabbit. Oh, 4. Jeez, check the notes, Mr. C. There we go. Add them up. 6, 3x. All that should equal 99. I'm going to come up here and solve. So minus 6, 99 minus 6 is going to be 93. We have tree x, divide by tree. X should be 31. Hey, you know what? Plug it in. Let's see if it works. 31. 31 plus 2 is 33. 31 plus 4 is 35. Grab your calculator real quick. And look, I'm checking. Maybe I'm wrong. Maybe I'm right. Maybe it's Maybelline. Who knows? Boom. I got 99. I got the right answer. So now I'm going to write it and put a box around it. Boop. So, as I said, flip your paper over. Let's knock out 5 and 6. And I'm going to be done for the day. Talk about rectangles when I get back. So 5, 3 consecutive even integers. I already know what to do. X plus 2, x plus 4, 1, 2, 3. 3 even integers. So 3x plus 6, all that should equal 228. I'll come up here real quick and give me some space to solve. Subtract 6. Oh, geez. Come on, computer. Subtract 6. That's 16 better days. 3x. 2, what do we get? 222. Look at all them 2's. Divide by tree. My soul tells me it's 74, but let me use my calculator. Dadgum, I got it right. Man, I'm smart. 74. So again, that idea, 74, 76, 78. Let's test it. You got a calculator in front of you. You can always, just takes a second to plug it in to make sure you're getting it right. Boom, nailed it. Those are my answers. 74, 76, 78. Go ahead and try this last one on your own. Pause the video and start it back up when you're ready. Alright, here we go. 3 odd integers. X, they use the same thing as the even, so x plus 2, x plus 4. Don't make that mistake of putting odd numbers here. Okay, 3x plus 6. And again, the computer's slowing down. Computer's ready to go to sleep. I'm ready to go to sleep. I still got work to do. Solving. See, here I go. I'm solving. 3x. 261 minus 6. 255. Divide that by tree. Let's see. I think that's going to be, I'm thinking 85. Let's find out. Shoot fire, it is 85. Telling y'all, I feel like I'm a wizard. I can just do this stuff in my head. Again, checking my work. Ugh. Let me do a better bracket than that. I don't need y'all judging me based on the curly brackets. Ooh, that one looks good. So, add that up. Here we go. 85 plus 87 plus 89. I get 261. So everything checks out. My answer is 85, 87, 89. Boom. It's late. Video's long. You got a lot of work to do.